So we're going to model data with a line of best fit. Line of best fit is probably something you've been doing since like junior high science even. So a line of best fit is a straight line that best approximates the trend in a scatter plot, right? A scatter plot is just a bunch of points. You take some observations and you plot them, and those points, which are kind of scattered, are called a scatter plot. When we have a scatter plot, there's two things we can do with it and a line of best fit. There's interpolation. So inter, the process used to estimate a value within. Okay, so inter or within, inside. Leave them open. Leave them open? Leave them open. Oh my God. Extrapolation, the process used to estimate a value outside. Outside, so extra, think of that as being outside the domain. Okay. So interpolation will be within the set of points. If you've got the graph there, it's inside the points, inside the domain, and extrapolation goes beyond. So a research student was guessing a relationship between job satisfaction, J, as measured by an employee on a scale from 1 to 10, and productivity, P, as measured by the employer on a scale of 1 to 100. Data from 12 employees is given in the table. Okay, so we have this data. So you would think the higher the job satisfaction, probably the higher the productivity, right? If people like their jobs, job satisfaction, then they're probably going to be more productive. So we've got this scatter plot of this information, right? So we've plotted the points here. And we're going to ask you to draw a line of best fit using a ruler. Okay, you don't need a ruler. You can just kind of eyeball it. Draw a line of best fit and explain the reasoning used to draw the line. So if you have a ruler, great. You can use the edge of your textbook or whatever, or you can just eyeball it and draw yourself a straight line. Which is what I'm going to do, because I don't think there's a line tool on this. So, I don't want it. Kind of want to draw a line of best fit. So we're looking for generally as many points above as below. So this probably could be shifted. I might be able to shift it actually. Let me grab this line. Nope. Maybe be shifted up a bit, but that's fine. Explain the reasoning used to draw the line. So we want about as many points above as below. If there's, this point's fairly far below, so that's kind of balanced by the fact there's more points that are above, but they're closer. So a straight line. Straight line. With as many points above as below, as many points. Use 2 points on your line to determine the equation in the form P. Okay, so P is our y-axis, right? P is equal to mj plus b. So this will be the slope of the line, this will be the y-intercept. The slope y-intercept. So we're going to pick a couple of points. I've got these guys here. So let's say we use this. Let's say this point's on the line as well. So we want the slope, which is the rise over the run. So this point is at 10 and I believe 98. And this point is at 3 and 44. So those are the 2 points I'm using. You might be using different points, okay? So slope is, rise over run is y2 minus y1 over x2 minus x1. So that was the point 1098. This was 344. So our rise is 98 minus 44 over 10 minus 3. So what do we got? 4. We got 54 over 7. So that's going to be 749 5/7. 7.1. Okay. Got a calculator, we can work that out. 54 divided by 7 is 7.71. And our y-intercept, okay, so we've got 2 points, gave us the slope, and our y-intercept, let's just say, is down here at around about maybe 14. 7.71 j plus 14. So we're using these points to come up with a model, right? This equation where if we know the job satisfaction, then we can estimate the productivity. Now, use your calculator to find the linear regression function for this data. Okay, so let's go back up here. So our x's are the j values. These are our x's, and they are in list 1, and our y values go in list 2. So let's get the calculator out, and okay, so the first point is 3. All right, so you can clear your calculator, but let's say if we've done other regressions, then let's just go second function and the plus sign into the memory menu. And we'll use number 4, which is clear all lists. So hit number 4, says clear all lists, hit enter, it says done. That clears out any of the lists. So if we've already run a regression, this will clear that out. Okay, we go to stat, and we want edit. So in L1, we're going to put the x values. So 3, 8, 7, 5, 9, etc. So I think I can do that. I can do that from here. 3, 8, 7, 5, 9, 6, 6. Okay, backspace. 6, 6, 10, 8. So I've got 12. There should be 12. So here it should say, I don't know if it gave us the number of them. There are 12. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12. Then we move over to L2, and we put in the job satisfaction. So 44, 81, 75, 66, 90. And occasionally what I do is just sort of look across. So if I just put in 90, that should be with the 9. Okay, so just, make sure you're on the right line. 70, 71, 98. 98. 75. 25. 68. 77. Okay, now you notice, see I got the 7 there instead of the 77. I'm going to leave that because we'll see it. I mean, you can do yours right. We'll just see that it's wrong and then we'll fix it. Okay? So then what we want to do is we want to look at the scatter plot. Okay? In other words, what we see here, plotted here, we want to look at that on the calculator. So we take a look at our job satisfaction, and it's a scale from 1 to 10. So, okay, we're going to go 1 to 10. So let's go into the window. And we want our X min. So, you know what, I'm going to go 0. 0 to 10. And we'll do that by ones. And the Y min is 1 to 100. We'll go 0 to 100. and we'll do that by tens. Okay, now if I hit graph, nothing's going to happen because we have to turn on the stat plot, right? We're doing a stat plot. So to do that, if you go second function y equals, which that wasn't, okay, that won't be, that. Okay. Second, and then y equals takes you into the stat plot menu. And we want to turn on plot 1. Okay, so we just hit enter and we turn it on. And everything else stays the same. Okay, so we never have to go in and change any of the stuff there. No matter what kind of regression we're doing, whatever we're doing, just, excuse me, if you work with a cleared calculator, you enter the stuff, all you got to do is turn on the stat plot. Okay, it's on now, and then I'm going to hit graph. And I'm going to notice and say, wait a sec, that doesn't seem, I don't remember anything that low. What's going on? And I can go back into stat. Okay, so I'm going to fix that. So I just noticed that looks out of place. Go to stat, edit, and start matching them up. So it's a really good idea on any test, and especially on the diploma, to go through the list 2 or 3 times, right? Because if you enter any one number wrong, everything's going to be off. Okay, so you will not be able to get any marks if you just enter one number wrong. Okay, so just going back through 3, 8, 7, 5, 9, 6, 6. So just double check. And here I'm just looking, oh, that's the one, 7 should be a 77. 77. Hit graph, okay. So, oh, that looks better. So we want to do a linear regression, right? Today is about linear regression, the line of best fit. So we go to stat, over to calc. Linear regression is number 4. Okay, so either you see a screen that looks like this, or you just see the word lin reg and then an open parenthesis next to it. If your screen looks like this, just move down to the store regression equation line. If you're sitting looking at the word lin reg with a bracket next to it, then fine, we're all at the right place now. So what we want to do is, we're saying to the calculator, run a linear regression and put the equation into y1 so that we can do stuff with it. So how do we get a y1? We hit the vars key, we arrow to y vars, function, we want function, and we want y1. Okay. So if your screen looks like this, just hit enter twice. Enter once will move to calculate, enter twice will do the calculation. And if your screen looks like lin reg and just y1, just hit enter, it'll do this. And you'll be looking at this. So this equation, the linear regression, will be y is equal to 7.91x plus 19.89. Okay, if we were doing that in terms of P and J, right, then P is equal to 7.91J plus 19.89. And you see, this is the one that I came up with by using the line of best fit that I drew. So what do you think is more accurate? The one I came up with, or you came up with, or the one the calculator came up with? Yeah, so the calculator one. How does this compare? They're not far off, right? This said 7.71. This is 7.91. This is 14. It's closer to 20. Okay, so that's a little bit further off. So the calculator will be more accurate, right? It's just using a mathematical method to give equal weighting where the points are, and based on that. It's a method you don't have to worry about, right? You can just use, you don't have to worry about how it's calculated. So the calculator will be more accurate. And the other thing, so if I go to the calculator for a second, if we go look at y equals, so the reason we did the whole bars, y bar, enter thing, was to get it to put the equation, right, that 7.91, etc., into y1, and you notice it's full accuracy here, right? Like that's like 12 decimal places or something. So if I then hit graph, we're going to get our scatter plot, and then because we put that in y1, it's going to draw that line. Okay, so I'm just going to hit graph. So there's the scatter plot. There's the line of best fit. And we can see pretty close to the one I drew, kind of. Right? I was going through those points and that one there. Because we have a number of points above, but we've got this one point pretty far below, and then these two guys a little bit below. So, anyways, that's your line of best fit. And we're going to use that to interpolate. So interpolate means we're going in between, right? So we've got a low of 3, I think, right? That point there. I think the trace gets you there, but yeah, so trace will move you. So that's 3. Yeah, no, I don't know what trace does. I think maybe it moves you along the point, but 3, we've got values going from like 2, I guess, 2 to 10. So anything between 2 and 10 will be interpolation. The job satisfaction is our x value, right? So there's job satisfaction there, which is an x value. So what we have is when x is equal to 4. So here's how we do the calculator. Give me the y value when x is equal to 4. We go second function, calc. So into the calculate menu. Number 1 is value. So number 1 says, you give me the x value, I'll give you the y value. Okay? So the calculator says, you give me x. Okay, we say x is 4. And then we hit enter, and it will give you y, which is 51.53. Sorry, 51.54. So 51, well, let's just round to the nearest 10. 51.5. What if we were rounding that to the nearest whole number? 51.538, etc. What would that be to the nearest whole number? 52. Okay, don't double round. So what I mean by that is if this was 51.49, and I said to the nearest 10, you would say 51.5. If it was 51.49, and I said to the nearest whole number, then you would say 51. So you wouldn't sort of take 51.49, round that to 51.5, and then round that to 52, right? We always just round to wherever it is we're rounding. Okay, so we don't sort of cascade the rounding, don't keep rounding, oh, nearest 100, then 10, then whole number. If you're rounding to a whole number, you just round to a whole number. All right, so that is interpolation, reading in between. If another employee was surveyed and they had a job satisfaction level of 4 with a productivity value of 52, how much is that different from the estimate of your actual value? Well, not at all when taken as a whole number. So not at all. Round it to the nearest whole number. Now, values in our table go from 2 to 10. So if we go outside of the domain, the number from 2 to 10, that would be called extrapolation. So extrapolate a possible productivity value if an employee has a job satisfaction of 1. Okay, so we go second, calc, value. Okay, so second calc value is used when you have an x value. Okay, it could be time. In this case, job satisfaction could just be a plain old x. And you want to get the y value. So you're saying, give me the y value that goes with an x value of 1, and it says 27.8. Okay, so extrapolate goes beyond the data that you have, right? It's either lower than the lowest domain number or higher than the highest domain number. If another employee was surveyed and they had a job with a productivity value of 27, how much different is this from the actual value? So it's 0.8. Lower, you know, but effectively it's the same. So effective, which is spelled effectively the same. It's not like it's out by 10. Oh, 37 with a job satisfaction of 1. So, no, that's way off what we would expect, right? So what this is doing is just saying, so what would we expect? Okay, and we can see, you know, the scatter plots could be a lot more scattered. There could be stuff here and stuff there, but that's not the case here. Things are pretty close to this line. Part B, Antoine works in a department store and his weekly salary is partly dependent on his weekly sales. The data below represents his salary and sales for the last 6 weeks. Make a scatter plot of this. Okay, so we're just going to go in. Second function, memory, right? Go into number 4, clear all lists, and clear all of the lists. So just clear everything out of the list. Makes it easier to enter. So notice they give you the X and the Y, right? So that's L1, L2. And generally speaking, we will give you the X and the Y. Sometimes in the book, the questions can be a little funny where they put the Y's first and then the X's, but you know, that's weird. We won't do that to you. We'll make it very clear this is what goes in. These are your X values. They go in L1. These are your Y's. Okay, so we go to Stat, Edit. Arrow back to L1. Okay. Now, if you're ever having any problems with anything with the calculator, just reset it. Okay, just do a reset. Okay, let's go put these numbers in. Five, 8, 0, 0, 8, 1, 2, 5, 7, 1, 5, 0. Okay, when you've got all those in, just a right arrow to take you to L2. And we put in these numbers. And then double check your numbers, make sure that that they're correct. Right? Otherwise, everything gets wrong. Everything goes wrong. 8, 722. Okay, so I'm going to go back and look. 4550514. And if you want to look at numbers, sometimes one way to do it is just to arrow up to the top and just look down here because the numbers are a lot bigger, so it's sometimes easier to see. And if your numbers have a lot of decimal places or something, up here they'll round, but down here they'll be shown exactly as they are. Okay, so we can just kind of arrow 514, 736, 644, 614, 800, 722, 7150, you know, going up, 8125, 5800, 6170, and 4550. Okay, so we're going to need a window. So if we look here, our lowest value is 4550. Our highest value is 8000. These are our X values. Let's go to the window. So maybe we say, well, let's go from 4,000 to 10,000. And we could do that by thousands. Okay. Scale is really about the least important of them. I mean, it just gives you sort of an idea. If you see something a couple of ticks over, you say, oh, that's like 6,000. And here, 514 to 800, maybe we go from 500 to 1,000. So Y min 500, Y max 1,000. That's a bunch of zeros, 1, and 3 zeros. And again, let's go by hundreds, or we could go by 50s as well. $100. Okay, go to y equals, clear out what's in y1, okay, and then you can hit graph. Okay. So if you see a curve on there and you know, wait, I haven't run a regression yet, then you just go, oh, wait, that's from a previous one. Okay, and again, if anything gets confusing, just clear the calculator, start over. Okay, so there's always time on a test, whatever, to just go back and re-enter some of the data. Okay. So let's run the regression. So okay, first of all, is this a straight line? Yeah, it sure looks like it's in a straight line, right? Use the regression function. So on any test and on the diploma, they will always tell you what regression to run. Okay, because we will be doing the following regressions: linear, cubic, exponential, logarithmic, and sinusoidal. Okay, so linear, cubic, quadratic, linear, quadratic, cubic, exponential, logarithmic, and sinusoidal. There'll be 6 different regressions that we're going to study in this course. Okay. Anytime that we ask you to do one, we're always going to tell you what type of regression to do. Okay. So if it says line, you do linear. Okay. Otherwise, it'll say quadratic, cubic, or whatever. Okay. Stat. Over to calc. Number 4 for linear. You got to, again, figure out how your calculator works. If you have a calculator that looks like this, there's another way to get the y1. Okay, you can go the green, alpha F4, and then number 1 is y1. Okay, so if your calculator is the older one where you're looking at lim reg and then a bracket, you got to do bars over to y bars, enter, enter. If your calculator looks like this, then you can do alpha F4 and hit enter. I mean, it saves you 1 keystroke, right? So let me just clear this. So the bars over to y bars function y1. That will work on any calculator. Okay, once you've got the y1 in, regardless, on this calculator, hit enter twice to actually calculate it. And it says y is equal to 0.08x plus 150. Okay, so what you can't write down is this. Don't write down y equals ax plus b, here's a, here's b. Okay, that gets you no marks. You actually have to write the equation, right? Equations are always in the form something equals, right? So equation is the equals, but it's equal to something. So in this case, y equals. I think it says to plot it on your scatter plot, so just hit graph. So first thing it's going to do is draw the scatter plot again, and then it's going to put the line of best fit. And we can see that is, in fact, the line of best fit, right? Like it's right through every point. Okay, graph this function. Check. During a slow week, Anton's sales were only $2,800. Okay, now we got a problem, which is that we set our window from 4,000. So I won't be able to put in 2,800 if I'm starting at 4,000, right? So I'm just going to go, you know what, let's just go 0 to 10,000. And, you know, let's go down to the Y's and let's go from 0 to 1,000. So even though we might be not seeing a lot of stuff, like no point, so if I hit graph here again, we don't see any points down here, but it sort of gives us an idea of, well, what does this whole thing look like here? All right, so his sales, this is an X value, right? So we're going to do second calc the value, and then X is equal to 2,800. So second calc, number 1 is value. So if his sales, which are the X's, are 2,800, then the Y value will be $374. Right? The salary for the week will be $374. Is that interpolation or extrapolation? So if it's in, that means it's between x values we have. Yeah, so it's extra, right? It's outside. Now in this case, because it's a perfect straight line, we can probably be fairly confident in this. So the deal with interpolation, be it for a line or a curve of best fit, interpolation is usually pretty safe, right? Because you're working within values that you have known points for. Extrapolation can always be a bit dangerous, okay? So extrapolation says, you're basically saying if the pattern continues this way, like especially if we're going with x values up beyond, if it continues this way, then this is true, but sometimes we don't really know. And we'll look at that more tomorrow with a curve of best fit. Okay, we'll look at some examples. What would Antoine's sales be? So what is the x? What is x if y is equal to 1,000? So salary is the y value. What we want to know is, how do you find an x if you know a y? So here's what we do. We know the y, so we go to y equals. We've got the equation in 1. We go down to 2, and we say, okay, if y is 1,000, and then we hit graph. And we could say, you know, maybe we should extend these y values up a bit higher. So I'm going to go to window. See, notice window went from 0 to 1,000. So I'm going to maybe go, let's say, what if we go to 1,500? And hit graph. And the next question is, well, we're not quite far enough on the x values, right? Not quite far enough, so we're going to extend our x values out a little bit further. Okay, so we may have to play with the window a bit. So the x max went to 10,000. Let's go to 15,000. Okay, so sometimes given a graph, we don't see it on the graph. We have to play with the window, adjust the graph so that we can see it. Okay, so what we have now is, here's a y value of 1,000, right? Remember a constant function? Okay, or the first thing is get a constant function. Now we have to do the intercept. Yep. So constant function is a horizontal line, right? This is a constant function of y equals 1,000. Everywhere on that line, it's 1,000. We want to know what's the x value, so we do an intersect. Second calc, intersect. Okay, now we know the y value would be 1,000. So here's how I do an intersect on the calculator. So notice it's asking for the first curve, and then when you hit enter, it's going to ask for the second curve, and then when you hit enter on that, it's going to ask you for a guess, as in where are they? Let's just go straight to where it is. So if I move right to the point of intersection, or as close to it as I can get, right? So it's asking for first curve. I'm going to hit enter. It's asking for the second curve. Now what it's done, and you can't see it, is it jumps from the blue line to the red one. Okay, but we're really in one spot. So just hit enter there. And then it asks for a guess. And so the reason that I move right to that spot is because I'm going to have to get there at some point. So why not just go there right away and then just hit enter, enter, enter. Okay, one more enter. There's our y value of 1,000, no surprise there, and the x value is 10,625. Okay, so 10,625. Usually we don't do commas, we do a space. So given an x value, its second calc value, put in the x value, you get out the y value. Okay, that's the easy one. Given a y value, you have to go y equals, and then you have to find the point of intersection. How much would his weekly salary be if he had no sales for the week? Okay, so it's going to be second calc value. Okay, the x is the sales. X is equal to 0. Second calc value, put in 0, we get $150. So this guy here, the 2800, was extrapolation, right? It was outside of. This, because it was 10,625, right, is also outside. So this is also extrapolation. And this is also extrapolation, right? So they're all extrapolation. Interpolation would be something like, what if his sales were $5,000, right? It's 5,000 in between these. What if his salary was $750, right? The 750 is in between these. So interpolation is in between, right? Inter lies in between values. Extrapolation is outside of, extra, right? Beyond. So either lower or higher.